Hi, everyone. First of all, well done for making it this far. I'm the last speaker, so I'll try and keep you entertained. And hello to everyone online. Hope you're still there. So I'm Paul, and I'm going to be speaking to you about AI to enhance doctors and not to replace them. So, I mean, we've all seen in the news over the last year, the last few months, AI is everywhere. It's advancing, it's progressive. It has many benefits. There are many possible downsides. I'm sure we've also seen AI may replace people's jobs, and they've even spoken about AI replacing doctors' jobs. Now, I'm quite clearly biased, but I think there will always be a role for a human doctor. But I do think that these tools could have a great impact and make doctors' lives a lot easier, make them more efficient, and give them more time to spend with patients. So why am I talking about this anyway? So I am a doctor myself, and I have over 6 years of postgraduate experience working in the UK in the National Health Service. It's the NHS's 75th birthday today, actually, since it was founded. And with that, I've been long frustrated with the current systems. I myself have been overworked. The use of information technology systems is very poor. And for me, this has personally led to a degree of burnout. But I do see the potential, and I'm quite motivated to solve some of the many existing problems that I've encountered. And that's kind of what's brought me here, really. So what are these problems? Well, major problems. As I'm sure you all know, with aging populations, we have increasing patient numbers relative to the number of doctors. This leads to unsustainable workloads. Doctors are tired, they're exhausted, they're overworked, and a lot of them are burning out. Record numbers are leaving the profession. In the UK, many are changing jobs, or lots are moving to, say, Australia and New Zealand. And this creates a vicious cycle, increasing patient numbers relative to the number of doctors. It goes on. Here are some headlines. This is only from 5 days ago in the UK, but NHS in Wales and GPs face collapse. As patient levels rise, numbers of GP surgeries and doctors are falling amid inadequate resources and unsustainable workloads. And I'm sure the picture is similar in Germany and other countries. This is from the British Medical Journal. Almost a third of UK doctors may be burnt out, the poll suggests. And from the American Medical Association, burnout is a health crisis for doctors and for patients. And it says here, it says the reasons are ever apparent, and it mentions the ever-increasing administrative burdens and hassles. So let's be a little bit more specific. I'm going to talk to you about two main problems that I encounter in my work on a daily basis, and then I will come to speak about some possible solutions that I've come up with. So focusing on the administrative burden, again, from the American Medical Association, highlighted in blue, nearly a third of physicians said they spend 20 hours or more a week on paperwork and administrative tasks. I'll just let that sink in, 20 hours a week. It's quite significant. From the New England Journal of Medicine, half of physician time spent on electronic health records and paperwork. And just to make it a little bit more tangible, I was speaking to my dermatology friend and colleague last week. She says, on average, she spends 2 hours a day on this kind of paperwork, and she actually has a half day rotated in twice a week in order to complete it. And for my own personal work, this is a kind of workflow. I would see a patient in the clinic. I would dictate my letter on a dictaphone, sometimes with an actual tape, but usually electronic. This would then go to a secretary who would either type it up themselves or the letter would be outsourced to a different country. I would then receive the letter back to myself in a week, and at best, the letter itself would have lots of errors because it was typed up by a human who's not medically trained. I would then fix it and then it will get sent off. I think we can do better than that. And that's with a human helping me with the documentation process. The other problem I like to focus on is accessing clinical guidelines. So good doctors regularly refer to up-to-date clinical guidelines. These are the gold standard evidence base, what we all work with. They're found in various places. You have local guidelines only accessible on hospital intranets. You have national and international guidelines published. And I can say from experience, finding the right section of the right guideline to answer your question in a way that is quick and not frustrating is a challenge. And subsequently, doctors may not look at the guidelines, or they may just ask Dr. Google. And I know I've been guilty of that sometimes, but not many times. So what can we do about it? I'd like to introduce you to STEPH, some of the things I've been working on, smart technology enhancing patient healthcare. And the idea behind STEPH is to try and use some of these technologies, AI-driven tools, to help doctors with their work, maybe automate some of the boring tasks so they can spend more time with patients and ultimately improve their experience and the patient experience. So I'm going to talk to you through two solutions, if you will indulge me. The first solution, STEPH Scribe, So in its current form, it's an app, which is an automated clinical documentation of doctor-patient consultations, which is returned to the doctor within moments so they can review it before it's signed off into any sort of proper medical records. And also STEPH Scope to tackle the second problem, which is a fast, efficient, up-to-date answers to clinical queries from across the spectrum of clinical guidelines, all in one place, or with one query. So going through the first one in a bit more detail. With the app, you simply record a consultation, and in moments you receive an email in its current form with a clinical letter, the one that would take a week or so to come back to me, a consultation summary data, and a transcription to review and reference to see if there are any mistakes. This could potentially save huge amounts of time. A modest estimate would be about an hour a day. The doctor remains in control of this process, and it's achieved using advanced automatic speech recognition and large language models. So I'm going to be bold and go straight into it with a live demo. So if my trusty patient assistant could come up. Hello, I'm the doctor. Welcome to the clinic.
Hello, nice to meet you.
And how may I help you today?
Well, I have been experiencing worsening shortness of breath recently.
I see. Could you tell me more about that?
Yes, it has been for the last 3 weeks, and it's getting worse. It is particularly bad at night, when my chest also feels very tight, and I have a cough.
I see. Do you feel wheezy when your chest is tight?
Yes, very wheezy.
Are you coughing up anything?
Yes, just some clear white stuff at times.
Any symptoms before this?
Not really, I was okay.
Any previous history of asthma?
No, nothing like that.
Do you have hay fever?
Yes, hay fever.
Any other medical problems?
I have an underactive thyroid gland.
See, any regular medications?
Yes, thyroid medication and occasional painkillers for the migraines.
Any allergies to medications?
No allergies to medications.
Any smoking?
No.
Okay, so in summary, the symptoms you described may be due to asthma. I'd like to start you on a regular corticosteroid inhaler and an additional blue reliever inhaler for when you need it. Does that make sense?
Yes, thank you.
Okay, great. I'll arrange to see you again in 2 weeks. So we've recorded the audio. It's gone off to the cloud. It's gone into an AWS bucket. This triggers off a AWS Elastic Container app, a Dockerized app, where it's, first of all, the audio is sent to a automatic speech recognition model, and I'll go into this in a little bit more detail coming up. Then the transcribed audio then goes back, and it has lots of different processing steps using large language models, but essentially it's chunked up so it can be an adequate size to go to the large language models. The chunks are now at number 4. The chunks are summarized. You can do additional things like work out which speaker's which, do some sentiment analysis. Then the chunks are concatenated, do a second summarization, so you have your overall summary. Then you write your clinical letter to whatever template you desire. And then all of these things can be put in a report. So the report can contain the transcript with the correct doctor-patient names. It can contain some data from the transcript. You can have your overall summary, which is good enough to go into the clinical notes or to be edited. And then you have your clinical letter. So that's emailed. Okay, so what's going on? I'll speak in a bit more detail about the models. The first step is the transcription. So it's using automatic speech recognition. And as I'm sure many of you know, transformers have changed the game in natural language processing with large language models, aka ChatGPT. They've also changed the game in terms of speech to text. And OpenAI released Whisper in late 2022 in September. And this is a sequence-to-sequence encoder-decoder transformer. And it's trained on 680,000 hours of labeled audio data. It's open source, completely open source, unlike GPT. And it achieved state-of-the-art performance on a few benchmarks. So 3% word error rate, for example, on LibreSpeech. That's just a labeled audio data for benchmarking. Word error rate is the sort of standard metric used to assess these models. It's basically looking at the number of substitutions, additions, deletions of words as a ratio to the total number of words. With the speech recognition, you have your audio, it's processed, and you visualize in the form of a spectrogram. And then you have 2 main pathways. You have the speech recognition, which is working out which words were said. And this is using something like OpenAI's Whisper sequence-to-sequence transformer model. You also have a process called diarization, and this is very important. Diarization is who is speaking and when, and then PyNote is an open source model which uses a long short-term memory deep learning model to do speaker embeddings and separations. And I won't go into the details about the model, but essentially you're able to see which speakers are speaking when. And then you align these in time so you can have your final diarized transcript saying speaker 1 saying this, speaker 2 saying this. DeepRAM is a very useful API which sort of speeds up the process, which I have used in addition to some of the open source models. So just to some evaluation, I wanted to evaluate these models on myself. So I used data which was available on Kaggle, but it's produced by Figure 8, but essentially 8.5 hours of labeled audio data of symptom complaints. So talking about symptoms, some medical terminology. And these are, again, the word error rates, which is the standard metric. We can see how well Whisper performs. And then we can also see DeepRAM Nova's model there. Just to give you an idea, these are the number of parameters in the Whisper models. So the large, which is clearly seen as the best performing, has over 1,500 million parameters. The small model, which is performed very well, has 244 million. Of course, the larger the model, the more computationally expensive it is, the longer the inference time, so it becomes less useful in practice. So a balance is something like using the Whisper Small or the DeepRAM Nova models. Now, you may have noticed there's a fine-tuned model there. I took the Whisper Small model and I fine-tuned it on some of this data, and it achieved quite a significant improvement. Of course, this isn't being extrapolated to all the scenarios you're going to face in medicine, but it shows you what can be done with some fine-tuning of the Whisper-based small model. So there's a lot of potential there. I also uploaded it to the Hugging Face Hub if anyone is interested. So just touch on the next stage, which is the language processing. We've already heard a lot about OpenAI's language models. Currently in this model, I'm using GPT 3.5 Turbo 16K. We've already heard it has 175 billion parameters. What is interesting is only in the last sort of 2 weeks, OpenAI increased the context window from 4,000 tokens to 16,000, which is a 4-fold increase, quite significant. Useful for these tasks because it means less chunking up of the transcript when you're processing it. And it performed very well with summarization tasks. So an overall evaluation. Again, I evaluated it on a different data set. This is 80 hours of simulated patient-doctor consultations. So these are consultations lasting 15 minutes. And I didn't want you to take my word for it. So I took random selection and I asked 4 clinicians to independently evaluate them on some predefined metrics. Things like the quality of the letter, the overall accuracy, and the number of major or minor mistakes. Mistakes being things like substitutions, deletions, or unnecessary additions, which we may refer to as hallucinations. First of all, there were no major mistakes, and there were only 2 minor mistakes. And these are what they were. So ramipril, which is a blood pressure medication, was incorrectly spelled as remipril. And in the family history of 1 letter, the patient's mother actually had a hysterectomy, but it said that they had an appendicectomy. And both of these are a fault of the transcription speech-to-text model, not the language model. So here's the letter that comes out. This is just from the transcription, just from the consultation with myself and Monica. So medical problems. It's picked up that she has potential asthma, hay fever, and underactive thyroid. The medications mentioned. This is a very appropriate letter, which I won't go into much detail. It has the summary, which is just what we talked about. It's quite brief because it wasn't very long. You can get some summary data, who is speaking when. You can do some sentiment analysis. This isn't validated, this part yet, but just shows some of the potential to see if the patient was satisfied, how long was the consultation. This part I will go into later. And then here's a transcription, which shows the correct doctor-patient labels, and you can verify it and reference it if you need to. So, okay, bear with me. We'll go on to solution 2. Worth concentrating on this part because I'll try and bring it all together at the end. So, remind you of the problem. Guidelines, they're everywhere, but they're very important to use in practice, and you want to access them quickly and efficiently. I've created a tool that can provide efficient search of a curated corpus of clinical guidelines. And it's similarly to what we've discussed already, it utilizes sentence embeddings, vector databases, and similarity search in order to find the right place. And then on top of this, you can use retrieval augmented large language models, and this will provide a specific and accurate answer to the query purely based on the guidelines, which is what you want. Here's a flow diagram, a little bit overwhelming, but I'll talk you through it. So on the left, at the top, we have our corpus of guidelines, and this can be anything you like, PDF, docs, HTML, it can be local guidelines, national and international, and this is curated by the organization. Data is extracted, and this is in the form of text and tables, as well as additional metadata. So the title, the authors, you can add links and whatnot. The pages are then chunked up. Chunking is done in a sensible way with tools, so it usually chunks out into different sections as opposed to half of the sentence. On average, a page is about 2 chunks. Then, this is the important part, using a pre-trained transformer language model to create embeddings of the chunks. This is using Hugging Face's Instructor XL, which is fine-tuned specifically for query retriever problems. And then these are stored in a vector database, and this is an example of one using Chroma, which I used. This is all done in advance, not the time of the user doing inference. So at the top, in the middle, we have the input from the user. They put in their query. First of all, it goes through a check to make sure it's appropriate. They're not asking about a non-clinical query. It then does a spelling correction and then expands any acronyms, and this is to improve the quality of the search. The corrected query, and now I'm at the red number 3, uses the same model of embedding, so you get your vector from the query. And then we do a similarity search, and this all happens very quickly. We can do a similarity search with the vector database, and we can choose our distance or similarity measure. In this sense, it's cosine similarity, which is one of the most commonly ones used. We can choose the number of results we get, but I'll choose the top 4 results from this. And I did a little bit more here than the diagram suggests, but I also, as well as the top hit, I included the chunk above and below. This helped to deal with page breaks and things like this, just to have more information. So then the top hit goes straight to the top, and it can be rendered as a PDF, so you get immediately your guideline that you want. And an additional feature is using a retrieval augmented large language model. So you take your results and the query, you pass it to a large language model, and it's able to reason the answer to the query only with the provided information. So this means you can reduce risks of hallucinations, only use the information you want, use up-to-date information, and use information that's not available to the language model. Hypo-NA is hyponatremia, which is low blood sodium levels. So it's in the first step, it's corrected the acronym, it's improved it, and then it gives us our answer. So this is immediately the top hit, which gives us the reference, and it takes you to the correct page of the local guideline that you want, and you can scroll through this. It's a PDF viewer. You can also download it, search, whatever you like. This is the answer that the large language model was given based on this text, which is a good answer, and it gives you the references, and you can add links and things. You see at the top there's these tabs. This is the local guidance, and there's also national and international guidance. So in this case, we also have the European Society Endocrinology Guidelines. It gives us an answer to the query, the reference, and takes you to the page of the guidelines. You can see that these guidelines are very big, which is one of the reasons you want something to help you with efficient search. So well done for sticking with me. I'm going to try and bring it all together. This is one of the better bits, I hope, so stay with me. So how else could this decision support tool that we just discussed be used? Well, what happens if we put the two of them together? So we have back in the top left, we have my consultation with Monica. Again, we get the transcription, we summarize the transcription, and what if, as well as doing the other stuff, we take our summary of the consultation, we take the doctor's diagnosis and management plan, we summarize the key points of the rest, then we feed that as a query, we embed it using our embedding model, and then we do our similarity search with our corpus of clinical guidelines, and then we feed it to our retrieval augmented large language model, and then we can ask it to make suggestions or corrections to the doctor's management plan. And then this is fed back into the report, and this is emailed. So on this page, which is part of the report, it says here, based on the information provided in the clinical guidelines, here are some suggestions for improvement of the diagnosis and management plan. So it says here, the doctor did not mention any objective tests or examination findings, which is true. To support the diagnosis, it is important to perform spirometry and assess for reversibility to confirm the diagnosis of asthma. It also says the doctor prescribed a regular brown corticosteroid inhaler for daily use, there's an error there, and an additional blue inhaler. This is appropriate. However, the doctor did not mention any education, self-management advice, it is important to provide information on trigger avoidance, proper inhaler technique, and an asthma action plan. Now, I have done many asthma clinics in my time, and I can confirm that this is all completely accurate. But you don't need to take my word for it, because it's come from the British Thoracic Society Guidelines, which is highlighted here. And this is the gold standard guidance that you should be following. Where to go from here? Of course, a lot of these tools are very new. They need rigorous evaluation, especially if they have any hope of being used in a real medical setting with real patients. And of course, that's a very important consideration. I think going forward, fine-tuning the speech recognition models to medical specific audio is critical and will be very important, will massively improve. I think looking at replacing GPT 3.5, especially when it comes to data privacy and things like this, is an important consideration. Language models are improving very quickly, so open source models are more open to being fine-tuned and these sorts of things. It's very important to ensure these sorts of products are meeting the required data privacy and regulatory requirements. I would love to take this further and try and build a team, and I'd love to acquire feedback from end users, so doctors like myself, to try and improve these products. And ultimately, I would love to have partnerships with care providers to try and deploy and test some of these things. So thank you for staying with me. Just some closing remarks. I mean, it's very early days, but we can see the technologies are improving at a rapid scale. I think with the advances in both speech recognition and language modeling, combining these two has potentially very powerful effects, and it would be great to use them for something beneficial, like helping doctors with their work. So that's what I hope to achieve. So thank you very much. Thanks to my project supervisors, Marcus and Christoph, and thanks to ChatGPT for helping me with the acronym of the name and also for lots of debugging along the way. But yeah, thanks very much.